Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the
Good morning, our dear participants. Please welcome silence and avoid leaving in our Zoom because our event will start in a few minutes. Ladies and gentlemen, distinguished guests, and esteemed speaker, a very welcome to the virtual workshop on HAPS roles in 5G and beyond. I am Riesa Krishna Astuti Sakir, will be the master of ceremony for this insightful event. This event is brought to you by the collaboration between the Indonesia-ITU Council Forum, the IES-GRS Joint Chapter of the Institute of Electrical and Electronics Engineer IEEE, and the Politeknik Negeri Ujung Pandang, as being sponsored by PT Telkom Satelit Indonesia Telkomsat. At the commencement of this workshop, we will have a welcome speech by Dr. Arifin Nugroho, Chairman of IER's JRS Joint Chapter IEEE. Following that, we will have an opening speech by Professor Gamantio Hendrantoro, Chairperson of IEEE Indonesia Section. This will be followed by a keynote speech Mr. Kishore Babu Yarabala, Head of ITU Area Office for Southeast Asia, ITU Regional Office of Asia and the Pacific, on ITU and global perspective on broadband and digital transformation for 15 minutes. The following keynote speech by Dr. Denny Setiawan, Director, Spectrum Policy and Planning, Ministry of Communication and Informatics of Republic of Indonesia, on the Indonesia Vision and Policy on HAPS and broadband implementation for 15 minutes. The last keynote speech by Mr. Ken Riordan, President HAPS Alliance, on the status of HAPS as solution for delivering digital connectivity and service for 15 minutes. There will also be a photo session after the keynote speeches. Following that, we will have session 1 on technology and potential use case. This session will be moderated by Mr. Abdullah Basargan from Politeknik Negeri Ujung Pandang. The speaker for this session are Shiri Matsumoto, Chief Business Development, Space Run Business, Space Compass Corporation. Mr. Indrawan Suparan, Managing Director Caraka Consulting Co. And Dr. Arifin Nugroho, Chairman AES GRS Joint Chapter IEEE. There will be a question and answer session after session 1. Following that, we will have session 2 on implementation, challenges, and regulatory issues. This session will also be moderated by Mr. Abdullah Bazargan from Politeknik Negeri Ujung Pandang. The speaker for this session are Dr. Anggoro Widiawan, Chief Development Officer, Telkomsat. Unfortunately, Dr. Anggoro Widiawan could not participate in the event due to some urgent matters. Mr. Walt Anderson, co-founder and CEO of Evelto Ltd. And last but not least is Mr. Edi Setiawan, co-founder and chairman IICF. There will be another question and answer session after session 2. We will then have a summary and closing remarks by Mr. Edi Setiawan, co-founder and chairman IICF. Today, we gather to explore the fascinating development of HAPS and the 5G and beyond technology, service, application, and regulatory issues in the dawn of non-terrestrial network NTN system, which is strongly endorsed by ITU and 3GPP to hopefully enable 2.6 billion people connected through broadband. Through of this workshop, we'll hear from experts who will shed light on global and national policy, as well as on standards, technology, application, and regulatory in the path toward achieving meaningful interconnectivity and interoperability. So, without further ado, let's embark this journey of knowledge, collaboration, and envisioning HAPS as part of NTN roles in 5G and beyond. Thank you for joining us, and let's make this workshop an engaging and enlightening experience. Ladies and gentlemen, distinguished guests, and fellow participants, it's my pleasure to introduce our esteemed speaker who will set the tone for today's workshop. Dr. Arifin Nugroho, Chairman of AES GRS Joint Chapter IEEE, to deliver the welcome speech. As we embark on this journey of exploration, let us lend our ears to his insight. Without further ado, Please join me in welcoming Mr. Arifin Nugroho to the stage. Mr. Nugroho, the floor is yours.
Thank you. Thank you, Mbak Risa. Bismillahirrahmanirrahim. In the name of Allah, the All-Merciful, the Very Merciful. May peace be with you along with the blessing from Allah Subhanahu wa Ta'ala. Distinguished professors, distinguished keynote speakers, distinguished participants, distinguished guests, ladies and gentlemen. Welcome wholeheartedly to this virtual workshop of HAPS roles in 5G and beyond, an event being organized by GRS AES Joint Chapter of the Indonesia sections of IEEE and Indonesia-ITU Concern Forum and Polytechnic Negeri Ujung Pandang. Please allow me, on behalf of the GRS AES Joint Chapter of the IEEE Indonesia section, to sincerely congratulate and thank the organizer, consisting of a team whose members are coming from PNUP, IICF, and GRS-AES Joint Chapter. The same appreciation shall go to our sponsor, PT Telkom Sat, a subsidiary of PT Telkom, which has a business in satellite communications. Then we should thank two Indonesia sections of the IEEE through its chair, Professor Dr. Kamantio Hendrantoro. In fact, without such a genuine deliberation and support from all the said parties, this meeting could have not been run. The committee has realized the importance of the upcoming end-to-end technology and its impact to the advancement of the IMT and IoT services in the future, such as through 5G and its next generations. Our focus in this seminar would be on HAPS technology and its unique roles to the shaping of the future wireless network. While the efforts are being exerted on platform technology readiness, the international community such as 3GPP will be expected to refine standardizations in facing the requirement of interworking between different nodes and transmission links in the integrated terrestrial and non-terrestrial network with the use of HAPS, satellites, RFs, and free space optical as the network elements. We would certainly welcome any gesture to support the upcoming undertaking in this line, especially the standard bodies like 3GPP, research laboratory, and universities in making various kind of NTNs and its related interface standards. We would like to extend our gratitude to the following keynote speakers: Mr. Kishore from ITU office at Jakarta, and Dr. Denny Setiawan from ComInfo office, for delivering their important keynote addresses. Special thanks must go to the speakers for sharing their valuable knowledges, with special mentions to Compass Space of Japan, Avialto Company in the UK, and Skylo Indonesia. Thanks should go to our moderator for their lively moderating skill during the meeting. Last but not least, we should thank to the participants for their forbearance in following actively the conference, without which the meeting would be meaningless. So please enjoy the workshop. Now, before jumping into the next activity, may I draw your attention to the sudden disease of one of Indonesian hero in satellite communications, which is Mr. Dhani Indra Wijanarko, an RF and A satellite engineer who has passed away 27th of June 2024. We have lost one of the finest engineer who has dedicated his entire life for satellite technology and regulatory, the fiercest combatant in the ITUR coordination process. May God bestow with his finest blessing to him, and may God be satisfied with Pak Dhani. Thank you very much.
Thank you, sir, for your enlightening opening remarks. Your insights have set the stage for our discussion today. The next, our esteemed speaker, Professor Gamantio Hendrantoro, Chairman of IEEE Indonesia Section, will give the opening speech. Let's give a warm welcome to Professor Gamantio Hendrantoro. Time is yours.
Thank you. Okay, good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. First of all, let me introduce myself. My name is Gamantio Hendrantoro, but you can call me Gam for short. I am currently serving as the IEEE Indonesia Section Chair until the end of the year. I'm also a professor with Institut Teknologi 10 November in Surabaya in the field of telecommunications. That's why it is such an honor for me to be invited by the organizers of this workshop to give an opening speech. Welcome to the virtual workshop hosted by the Indonesia-ITU Concern Forum, IICF, IEEE Indonesia Section AES GRS Joint Chapter, and the Polytechnic Negeri Ujung Pandang, facilitated by PT Telkomsat. Our subject today, as you know, is on the HAPS roles in 5G and beyond. High Altitude Platform Station, or HAPS, as we know, as an aerial platform with a communication payload, has its own uniqueness in that it operates on an altitude much lower than satellites, but also relatively much higher than UAVs and, of course, as well as the terrestrial networks. Speaking of today's workshop on HAPS, held by Indonesian organizers, perhaps we should first understand why this subject is so relevant to people living in a large archipelago, having large population, with immensely varying density like Indonesia. In some areas like Jakarta or Makassar, we have perhaps almost full coverage of communication services, but people living in remote areas and isolated islands might have difficulties in accessing communication services. More than that, disaster resilience requires the presence of a fast and reliable communication access. Okay, satellites can provide services to people in remote areas, but HAPS can offer a stronger alternative in providing access with much smaller propagation delay and larger capacity per unit area, which can be enhanced further by forming a HAPS constellation. HAPS can also serve as an alternative to ground station for satellites, precluding the need for installation of many ground relay stations. These advantages make HAPS a very attractive technology for providing broadband services in a country like Indonesia. On the other hand, in the context of the new generation of wireless systems, we know that HAPS layer is part of the non-terrestrial network as defined by the 3GPP, which is consistently being developed into the 6G space air-ground integration. The deployment of HAPS as an IMT base station is also an idea that offers potentials in providing better access to users. With all of these considerations, I think it is clear that the workshop that we will have today is an important one for those who have an interest in developing communication infrastructure and services in Indonesia. We, the audience, will be enlightened and enriched in knowledge of various aspects of HAPS, ranging from the vision, policy, and strategy, but also technological advancements, standards, and regulatory works. Accordingly, I would like to express my sincere gratitude to the distinguished speakers who are coming from different countries and time zones. I would like to mention the names to show my appreciation. Mr. Kishore Babu Yerebala, the head of the ITU Area Office for Southeast Asia. Dr. Denny Setiawan, the Director of Spectrum Policy and Planning of the Indonesian Ministry of Communications and Informatics. Ken Riordan, the President of HAPS Alliance. Sherry Matsumoto, Chief of Business Development of Space RAN Business. Mr. Indrawan Suparan, the Managing Director of Kecharaka Consulting. And of course, Dr. Arifin Nugroho, the Chair of the IEEE Indonesia GRS AES Joint Chapter. Dr. Anggoro Widiawan, although he's not with us today. Walt Anderson, the co-founder and CEO of Avialto, and Mr. Edi Setiawan, the co-founder and chair of IICF. Last but not least, a great appreciation to our moderator today, Mr. Abdullah Basirgan from the Polytechnic Negeri Ujung Pandang. Finally, with the hope that our workshop today will be beneficial to all of the participants and that further advancements in the standards, regulations, policies, and implementation will follow, let us officially open and start this workshop. Thank you and enjoy the workshop. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
A million thanks to Professor Gamantio Hendrantoro for very energetic opening speech. Ladies and gentlemen, now we will listen the keynote speech. It's an honor to introduce our first speaker, Mr. Kishore Babu Yerabala, Head ITU Area Office for Southeast Asia, ITU Regional Office of Asia and the Pacific, who will present ITU and global perspective on broadband and digital transformation. Without further ado, please join me in welcoming Mr. Kishore. Time is yours.
Thank you very much, and hope I am audible clearly. This time cross-checking.
Yes.
Thank you very much. So, dear Dr. Arifin Nugroho, Chairman of AES GRSS Joint Chapter IEEE, Professor Gamantio Hendrantoro, Chairman of IEEE Indonesia Section, Dr. Denny Setiawan, Director of Spectrum Policy and Planning MCI, Mr. Ken Riordan, President of HAPS Alliance, and Mr. Edi Setiawan, Chairman of IICF, Mr. Abdullah Bajargan of Polytechnic Negeri Ujung Pandang, and esteemed panelists and participants. Very good morning and welcome you for this important event. And as taking forward the generous introduction from the moderator, from the MC, myself Kishore Babu, I'm area representative speaking to you from Jakarta. And I really appreciate to all the organizers, including the Indonesia-ITU Consent Forum and AES GRSS Joint Chapter of IEEE and PNUP with support from Telkomsat to arrange this important session, especially on the key role of emerging technologies and to adopt any and every technology to see that digital divide is bridged and digital transformation is taken to the nook and corner of Indonesia and of course the world. And I also want to congratulate the stakeholders here for hosting ITU Indonesia in Indonesia for the last 40 years, which is a milestone. And also ITU membership of Indonesia for the past 75 years. And kudos and congratulations to all of you. And I also take this opportunity to appreciate Ministry of Communications, Cominfo efforts, and all the officials and team for their extraordinary support through ITU as well as through their own digital transformation efforts, especially to taking forward the global objectives of digital communication development. Some of you may be aware that there is a high-level conference called Plenipotentiary Conference, which took place in 2022, where all the members, member states, they decided ITU strategic goals, especially for this particular cycle, or for especially to drive meaningful connectivity and sustainable digital transformation. These are the twin strategic goals which are very important. Whatever the efforts we speak about, using emerging technologies for connectivity, creating platforms, and developing applications, and skill development, everything goes into enabling and empowering through meaningful connectivity and digital transformation. And just a few days back, the ICT Development Index 2024 was released by Bureau of Development Sector, ITU. And in 2023, when where Indonesia marked 80.1, it went up to 82.8, which is around a 3% improvement, especially on universal score of 79.6 and meaningful score of 86%. So congratulations to all of you for inching towards UN aspirational targets as well as connectivity goals which Indonesia has set as part of its digital vision. And as some of the previous speakers rightly mentioned, connectivity in everywhere, that is rural and remote areas, using any technology platform, any technology connectivity, especially leaving no one behind, is one of the important objectives for all of us, and especially to address and deliver the digital opportunities to all, and also enabling access to telecommunications for human safety and security during emergencies and disaster management. You all know, especially the kind of geographic nature of Indonesia and as well as many countries, how telecommunications help during the times of emergency, especially to address disaster issues. And as you may, some of you are also part of some of the efforts of ITU area office and regional office in this region, especially on Smart Village, Smart Island, as well as AI standards and critical technologies project, which is going good in Indonesia. And again, thanks to all the participants and as well as stakeholders who have been either directly or indirectly have been part of this engagement. And some of you, may be aware about the ITU Academy platform, which provides a key element, capacity building and skill development in digital technologies and emerging technologies. And in 2024, already the catalog is released, which is having almost like 72 courses. Many of the courses are available to everyone and everybody just through registration, and most of them are free as well. So I encourage once again, all of you to take use of this platform, ITU Academy, especially the academic members who are present here, and technical organizations as well as consulting firms, to spread and disseminate capacity building efforts across the country and as well as the needy segments. And there are also ITU programs on digital inclusion, and thanks to Indonesian stakeholders who have been supporting for ITU's Girls in ICT event, especially to promote STEM education as well as girls and young women taking forward STEM career, and as well as exploiting and taking opportunity of ICTs, especially to bring them into mainstream and bridge the digital gender divide, and as well as enhance accessibility. So these are the key programs which are also offered from ITU. And I'm just returning from ASEAN meeting in Brunei. I returned back yesterday. During ASEAN Digital Ministers meeting this year in February, digital ministers approved and endorsed a publication of ITU, which was released in February this year, on especially the benchmarking, that is ASEAN benchmarking of policy and regulation best practices based on ITU's unified framework for policy and regulation. So I invite all of you to look at, if your interest is not only for Indonesia, but also for countries in ASEAN region, how and what are the gaps we need to address through all your stakeholders' efforts. And this particular study ranks all the countries, especially in the ASEAN region, how they are performing, what are the opportunities where they need to bring in terms of policy and regulation, so that they can go up in the collaborative regulation, because collaborative regulation and efforts towards digital transformation are very important to forward your objectives, as one of the theme here is about how these emerging technologies can support digital transformation. And while technologies may get developed, the important thing is about how policy and regulation frameworks enable them, so that especially the service providers and operators can adopt them, deploy them, because telecommunications ICT infrastructure is the one which requires a lot of investment in terms of infrastructure. So it's kind of capacity. Investment wise, it is very intensive. So my earnest request is the stakeholders who are here, consulting firms as well as the government stakeholders, please do look at this benchmarking exercise and how we can bring in enabling policy environment to adopt new technologies and emerging technologies, so that as quickly as possible, how we can adopt them and start taking the digital fruits. And maybe this from IEEE and other members, academic members who are aware, you might have heard about study group activities. And study groups is one of the structures how ITU functions and delivers its outputs, apart from conferences, workshops, and capacity building and project initiatives. In the radio sector has got 6 study groups, and the standard sector has got 11, and development sector has 2 study groups. And I invite all of you, please do visit ITU portal and also make use of ITU resources, because I can see here ComInfo members as well as academic members who may be already members of ITU. And of course, a lot of information is available even for non-members as well. Please look at and express your interest to make use of these resources, and engagement with the global network stakeholders on study group activities. And recently, the World Summit on Information Society process event, as well as AI for Good Summit, they completed, they got held in the last week of May, where you saw enormous support from all the stakeholders about this process, where the several action lines, capacity building, infrastructure development, adoption of technologies, etc., they play a very important role, and key contribution from stakeholders like IEEE as well as other agencies who are part of this discussion is very relevant. And we encourage your active participation in the study group events as well, because most of them are also offered virtual and online. So your contribution and your say matters a lot, especially to bring digital transformation more closer to meet sustainable development goals in the country. ITU also launched something called Innovation Alliance, especially for entrepreneurship and digital development. I can see, and I have spoken to some of the key stakeholders in innovation in Indonesia. We call it as a under agency BRIN, or even other stakeholders and other agencies, including in the industry like Innovation Factory and other technology innovation hubs. My invite is that please do look at how you can be part of this innovation engagement, which gives access to global networks, as well as to look at where and how you can see your product positioned, how your innovation could play an important role in achieving these objectives of delivering meaningful connectivity, as well as delivering a sustainable digital transformation. And one of the key steps perhaps is a kind of my I request my request, as well as I exhort you to look at how you can host more the study group meetings, as well as more workshops and initiatives from ITU, so that you get closer to international community, as well as you can involve more local stakeholders and the local ecosystem players in these activities. Because one is when events happen outside, yes, a delegation of certain key members can go and participate. But when the event happens here, it provides enormous opportunity for people to look at and nurture and ignite interest for all of them. So I encourage, and any of such interest for workshops and capacity building programs in partnership with ITU, please do approach us. And as I mentioned, we are located in Jakarta and hosted by Ministry of Communications. My office is part of the Kementerian Pariwisata, that is the Ministry of Tourism. And I also invite the industry members, stakeholders who are here to visit ITU office and understand about what works you are doing and how you can be part of ITU engagement. We have also created some of the informal groups. Perhaps, Mr. Edi Satyavan could also help us, to bring you into this engagement, to look at how the ITU study group activities, ITU standards, ITU policy frameworks, and as well as toolkits and the guideline books, handbooks, etc., can help you to forward your work. And once again, I appreciate all the organizers and as well as teams who are present here, who are having active role, especially in not only creating awareness and vision for new technologies, but most importantly, enabling policy frameworks to adopt new technologies so that they they complement your efforts in achieving the digital vision in Indonesia. With this, thank you very much for the opportunity for ITU to share some of these inputs to you. And more, as I mentioned, please do approach us, and we are available locally to support you in all your efforts. Thank you very much.
Thank you, sir, for the insightful speech. Move on the second keynote speaker, Dr. Denny Setiawan, Director of Spectrum Policy and Planning, Ministry of Communication and Informatics of Republic Indonesia. He will share about Indonesia vision and policy on HAPS and broadband implementation. Let's give a warm welcome to Dr. Denny Setiawan. Time is yours.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, and it is a pleasure for me to address this keynote speech. And first of all, I would like to thank the ICF, Pak Edi Setiawan and Pak Arif Nugroho, and Pak IEEE, Dr. Gamanti, Professor Gamantio, and the host is from Polytechnic Ujung Pandang, Pak Dr. Abdullah Bazirgan, and our previous speaker, Pak Kisari Babu from ITU, and all speaker. And this is a very excellent opportunity for us to share this new technology on HAPS roles in 5G and beyond. I hope through this event, we will get more knowledge and better understanding about HAPS and its potential use for enhancing Indonesia digital infrastructure and broadband connectivity with the challenge and potential. As mentioned by previous speaker, Dr. Professor Gamantio, that Indonesia is very large and diverse archipelagic country. Until now, there's a number, maybe more than 1,000 villages in Indonesia that still not connected to internet on terrestrial basis to these geographical difficulties. Of course, we can link by satellite, but sometimes the price is not affordable. Therefore, Indonesia needs many alternative technology solutions to provide coverage in rural areas. And the ITU developed with the concept of non-terrestrial network, an NTN. And the NTN plays an important role in ubiquitous and intelligent connection, also things for communication system. And the HAPS is one of the part of NTN. The other example of NTN is satellites, including LEO and GEO, and UAV, and drone, and so on and so forth. Referring to the ITU radio regulation, provision 1.16a, the HAPS is defined as a station located on an object an altitude of 20 to 50 kilometers and a specified nominal fixed point relative to the Earth. So it's different with satellite. Satellite is not part of our national territory, but HAPS is considered as fixed service. So meaning that it can be considered as the terrestrial, on the terrestrial component. But still, because it's not so-called terrestrial conventional like a mobile or fixed service, the HAPS is our HIBS, yeah, is part of the NTN. HAPS and HIP has the advantage of low latency, wide coverage, flexible deployment, and low construction costs compared to other space application. Would like to continue on the policy update of HAPS and HIPS. We have a two term now: HAPS, High Altitude Platform Service, and HIPS, HIPS is HAPS of IMT base station. HAPS for use IMT base station, administration post the last WRC. So for HIPS, HAPS for IMT base station, and based on resolution 2013, 2021, and resolution 28, there's quite numbers frequency like 700 and 900 megahertz with coexist with mobile cellular, 1.8 gigahertz, 2.1 gigahertz, and 2.6 gigahertz. That's identified as part of the HIPS. The HAPS is not as a IMT but as a backhaul, and was regulated and finalized in WC19. There's several frequencies already allocated in the 28 gigahertz in Ka-band, sharing with satellite, but different direction. 21 gigahertz, 31 gigahertz, I'm sorry, 39 gigahertz, and 48 gigahertz. HAPS or HIPS identification does not preclude the use of this frequency band by any application of the services to which they are allocated, and does not establish priority in radio liaison. And HIPS shall not also claim protection for machine prime service. So this is the reality that the spectrum, even this allocated, is shared with others, but also the conference and the ITU provide some recommendation rules how that can coexist to avoid the minimum interference from HAPS and other services. Move to the, I think that the mention of Pak Kishore Babu, yeah, on it's not only technical but how to adapt, yeah, in Indonesia. We need to look on the business model and licensing, telecom licensing consideration. So it's not only interference as such, but we need also to put which HAPS or even HIPS be part of the Indonesian telecom ecosystem. So technological development, of course, there's some benefit, and we need also consider also very careful on the challenge that from the spectrum issues on how to not interfere with others' service, but also with the telecom licensing. We have a lot of number of the incumbent telecom provider, for example. We have a lot of ISP, a lot of satellite provider, a lot of some of the mobile operators. So what would be the HAPS or even HIPS will be part of the ecosystem? Should be as the tower provider, should be as the backhaul, so the HIPS should be a new competitor. I think this very interesting discussion from newcomer. Of course, this is an opportunity for have new service as a competition, but for incumbent, yeah, do HAPS act as a threat? So it's a part of the discussion on policy implication, and we're happy to, if the ITU and others also discuss, maybe not in this meeting, that ISOM competition and business model for HAPS is very interesting. Learning from some issues, some hot issues recently on Starlink, which has been widely discussed, the implementation of HAPS and HIPS also has the potential, I think, so-called disruption. I remember when we put the result of WRC 23 last year, we put the result on our webs, and there's some comment, some concern from the tower operators do the HAPS as the new competitor, or should they work together with the incumbent network operator? I think it's very interesting. It's not only wholly the issue of spectrum internet as such, but also as so-called non-technical, non-spectrum issues should be considered. So with that, would like, so Indonesian, I think for Indonesia is a central country, HAPS has advanced in terms of coverage for regional disaster and timing, and also the cost, yeah, how from the operator point of view, that the total cost of ownership should be also comparable. And I think we need also to discuss the other regulatory, not only the telecom regulator, also the transportation, air transportation as well. Regulation said that on the how to launch the HAPS or HIPS platform to the airport or to the whatever it is, that should be part of the discussion. And but I believe, yeah, the HAPS or HIPS, even the NTN is not substitute, is not competition with the existing. It should be act as the complement, and how that we can play important role to unconnected and service, I think was the goal. How we can provide the most effective way, most efficient way, without hamper the, the competition. So apart from this NTN provide in general, I think there's also some option, and I think we perhaps quite new term in our regulatory term, what so-called the neutral host concept. Through this concept, like we actually have our experience on tower provider. So one tower provider can provide some services to even to for other non for as a neutral provider for all the provider the net telecom provider or network provider. So through this concept, HAPS might build the network and collaborate with the existing network, even the HIPS, yeah, the collaborative frequency, they are the existing network operators, and deal is the capacity to may know. In conclusion, its benefit has advantage and challenge, so that it can provide most benefit for nation, particularly provide affordable access for the people, particularly in rural areas. Of course, we expect that HAPS can be one of the puzzle that enrich our ICT ecosystem that can coexist harmoniously, both technically and also coexistent, act as complement, working together with others existing service effectively and efficiently for most of the benefit of the country. I hope that we can have the fruitful discussion, and we hope that we can learn from other countries. And I believe still quite new this technology, but we might also have some reference from international experience from the HAPS or HIPS implementation. That's I think that's with that I conclude my remark, and once again congratulations for IEEE, ITU, and Polytechnic Ujung Pandang, and other speaker as well, and hopefully that this can provide some benefit to this country. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Denny Setiawan for the insightful speech of Indonesia Vision and Policy on HAPS and Broadband Implementation. Next to the last keynote speaker, Mr. Ken Riordan, President of HAPS Alliance. But unfortunately, Mr. Ken Riordan could not participate in this event due to some urgent matters. Before we proceed, let's capture this moment. I invite all participants to join us for a quick photo session. Kindly turn on your camera and give your best pose. Smile. Smile, everyone. Okay, let's capture. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, thank you, ladies and gentlemen, for your photo session participation. Ladies and gentlemen, we shall break for 2 minutes before we move on next agenda. And I would like to remind you that this virtual workshop is again sponsored by PT Telkom Satelit Indonesia Telkomsat.
The leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider.
Ladies and gentlemen, welcome back. Now it's time to dive into the heart of our workshop. Our first session focused on technology and potential use case. And Mr. Abdullah Basargan, a lecturer from Politeknik Negeri Ujung Pandang, will moderate this session. Before that, I would like to introduce Mr. Abdullah Basargan brings a wealth of experience of more than 30 years as a lecturer in Politeknik Negeri Ujung Pandang, Makassar, South Sulawesi. His research interests in satellite communication and cellular communication as cellular network design, engineering ethics, entrepreneurship, and technopreneurship. Please join me in welcoming Mr. Abdullah Basargan to the stage. Mr. Abdullah Basargan, time is yours.
Thank you very much for Mrs. Rizka, distinguished guests, and participant, I would like to introduce our speaker. We have two speakers in session one. First, Hiri Matsumoto is a chief in the business development team at Space Compass Corporation with 5 years of experience working in the satellite communication industry in launching the HAPS communication project. She currently has an interest in technologies such as HAPS and 5G and 6G. Our speaker, another speaker, Mr.
Halo.
Ke-mute kayaknya.
Sorry first. Sorry. Okay, I repeat. I'm Abdullah Basargan from Polytechnic Negeri Ujung Pandang. We have two speakers in this session. Speaker number one. Hiri Matsumoto is a chief in the business development team at Space Compass Corporation with 5 years of experience working in the satellite communication industry in launching the HAPS communication project. She currently has an interest in technologies such as HAPS and 5G and 6G. Then our another speaker, Mr. Indrawan Suparan, he has experience in several companies like Skylo Technologies from 2019 until present as a business development director in Skylo. Another companies PT Alpha, Vintage Indonesia, SAF Technica, PT El Gayasa Media, and another company. Then last has experience in Lapan from 1978 until 1987. So I would like to invite Ms. Hiri Matsumoko to presentation. She's sorry. The convergence opportunity of multi-technology solution. Please, Ms. Hiri Matsumoto.
Thank you very much for the introduction. I'm sorry, the video is not working well at the moment, so I will turn off the video during my speech. But hello, everyone. I'm Chiri Matsumoto from Space Compass, and thank you very much for having me in this event today. So I'd like to talk about our company's future business plan using HAPS and how we think we can utilize HAPS can be utilized in Japan and other countries to realize better societies. But before starting my presentation, please see this video for our introduction. So please hold for a moment while I present my screen.
Natural disasters have frequently created areas without communication access. Even under such conditions, HAPS can offer resilient communication means for emergency support, rescue and relief efforts. Uniting the universe. Space compass.
Apologize for the sound trouble, but let me start my presentation using this slide material. First, I would like to briefly explain our company. Space Compass is a Japanese company which was established in 2022. NTT, a global leader of the telecommunication industry, and SkyPerfect JSAT, also known as JSAT, the Asia's #1 satellite operator, were teamed up to build a new non-terrestrial infrastructure called Space Integrated Computing Network business. Our mission is to realize the peaceful and fulfilling future by our endeavor to build a new social infrastructure that connects the Earth and space. This is the overview of our Space Integrated Computing Network concept. It will integrate multiple orbits from the ground to high-altitude platform stations, HAPS, flying at high altitude, low Earth orbit satellites, and geostationary orbit satellites. They will be connected to the ground through an optical wireless communication network to form a constellation to enhance various data processing by distributed computing. It will also provide access to terrestrial mobile devices for wide service coverage. In order to achieve this concept, Space Compass is going to start with the space data center business in the orange box and the space run business in the purple box, which includes our HAPS business. In the beyond 5G and 6G era, ubiquitous connectivity is expected for communication in all locations, including air, sea, and space. NTN technologies, especially HAPS, hold great potential in providing mobile broadband to unserved and underserved areas that have lacked sufficient coverage from terrestrial mobile networks. Space Compass is aiming to launch 2 types of services using HAPS in 2026. One is the direct-to-device connectivity service, and the other is the remote sensing service. For the connectivity service, we fly HAPS over certain areas based on our customers' requirements. Space Compass prepares the ground gauge station to connect the feeder link to the MNO networks. For the service link, users can directly connect their terminals, such as smartphones, to the flying hubs. Connectivity between the user terminals and hubs are enabled using 5G LTE frequencies, so the users are not required to prepare special equipment to connect to the hubs. For the remote sensing service, we fly hubs over the requested areas and acquire data, then deliver those data from hubs to the customers. Because HAPS is flying at high altitude, approximately 18 to 20 kilometers, HAPS can take high-resolution data compared to remote sensing services using satellites. We will first start the service with optical cameras, but we are also thinking to expand our service with other types of sensing devices such as SAR. So what are the merits of using HAPS? Direct-to-mobile phone service. Users are not required to prepare special equipment, such as antennas, when using HAPS connectivity. With smartphones, users can directly connect to HAPS using 5G LTE network, like we usually do with terrestrial mobile networks. Flexible design. HAPS are scalable from only one to several hundreds of aircraft. Not like low Earth orbit satellite constellation, HAPS can start its service with single aircraft. Also, we can flexibly design the service coverage to meet various requirements. We think it's possible to operate multiple hubs to ensure sufficient communication bandwidth in case of increased communication demand in certain areas, such as during disasters. Environmentally sustainable. HAPS aircraft can be 100% operated by solar power, and they can continue flying for weeks and months. HAPS are environmentally friendly infrastructure, which can reduce greenhouse gas emissions and mitigate climate change. Disaster resilient operation. Needless to say, HAPS is one of NTN infrastructure, and they're independent from existing terrestrial network infrastructure. They can keep serving despite disasters such as heavy rain and earthquakes. We believe countries with many earthquakes, like Japan and Indonesia, can benefit from this unique HAPS feature. HAPS connectivity service is expected to be used in many cases, as shown in the slide. Especially because HAPS can provide 3D coverage from the sky. We think there's high potential for new use cases such as drones and flying cars. Other use case is coverage expansion. In Japan, the population coverage ratio of the existing terrestrial mobile networks are more than 99%. However, the area coverage ratio is about 60%, and there are many places with no terrestrial mobile coverage, for example, mountain trails and coastal areas. HAPS can serve as crucial infrastructure to mitigate accident risks in such uncovered areas. Also, HAPS might become usable as an alternative to existing high-cost facilities. Although HAPS are expected to flexibly change their service locations depending on the customer's needs, they require ground gate station within the beam coverage to connect to the MNO networks. Space Compass is considering to have the satellite backhaul system for the feeder link, so that we don't need to install the ground gate station in the service area. We will still need the gateway station up somewhere, but this will enable more flexible operation in case of emergency usage. Here are some examples of HAPS sensing service use cases. Because HAPS can keep its station while flying, they can provide fixed point observation service. This can be used for change detection use cases, such as natural change detection, traffic monitoring and incident detection, and environmental change detection. Sensing can also be used for monitoring of movement of people, vehicles, and other static or moving objects. For example, land and maritime traffic and logistics, and disaster response monitoring. Today, imagery services with large low Earth orbit satellites are commonly used in many countries. While satellites follow the predefined orbit, HAPS can move and change their mission area based on customers' requirement. With high-resolution sensing image, HAPS can meet customers' specific needs, which low Earth orbit satellites cannot cover today. Japan is a country with many natural disasters. This year, on New Year's Day, a major earthquake occurred in the Noto Peninsula, Ishikawa Prefecture, causing ongoing damage. In addition to earthquakes, efforts to prepare for the increasingly severe typhoons and heavy rain disasters each year are becoming more and more challenging due to the impacts of a declining population and labor. We believe that if HAPS services can be realized, utilizing communication and remote sensing capabilities, they can be utilized for natural disaster recovery and mitigation efforts. Space Compass believes HAPS will greatly help those situations. However, it's also important that we understand the characteristics of each communication method, GEO, LEO, and HAPS, and suggest how we should combine those different infrastructures to ensure reliable connectivity. This is the roadmap of our HAPS business. At first, Space Compass is going to launch our HAPS service in partial areas of Japan in 2026. As we progress, we expect our service area and service capabilities to expand further. Space Compass is proactively working on the research and development of HAPS technology, supported by the Japanese R&D agency called NICT. We are committed to improving the quality, efficiency, and flexibility of HAPS services, extending mobile coverage to extreme levels, and ensuring seamless connectivity. Recently, we announced our partnership with Auto HAPS, a subsidiary of Airbus, and a global leader in connectivity and Earth observation services from the stratosphere. We've been collaborating with Auto since 2022 for the feasibility study of HAPS connectivity service. We believe that our strategic relationship with Auto will accelerate our activities to build a new telecommunications infrastructure in Japan and also in other Asian countries. We look forward to pioneering HAPS services and markets, contributing to a better world. Thank you very much, everyone, for listening.
Thank you for Ms. Sherry Matsumoto from Compass Japan. For second speaker, I invite Mr. Indrawan Suparan in topic the latest scenario of 5G and 6G development operational aspect. Please, Mr. Indrawan.
Good morning. Thank you, Pak Abdul. So let me share my screen. This, I hope. No, this is. Okay. Is my screen this okay or?
Not yet.
Or should I swap this? Okay. This is okay, right?
Still, Pak.
Oh, kelihatan Pak ya?
Not yet. Not.
It's not?
Yes.
Should be possible. Okay. Is it okay now?
Wait. Yes. Okay.
Yes.
Okay. Okay. Sorry. I use 3 screens. Sorry for this. So let me start with this. What's it called? Presentation. It's called the scenario of 5G or 6G development for operational aspects on using hubs. This is actually a very difficult subject because I do not know if I can do this in 20 minutes, but let's start with this outline. And this is actually an outline of, we start with what is 5G in the context of using it with hubs. What is hubs in the context of using with this 5G for the trial, the operational aspects, and the hopefully proposal of a trial using hubs for disaster, like the previous speakers has mentioned. So let me start with this. What is actually the 5G technology? Actually, of course, it's simple answer is 5G is we start with 1G, 2G, 3G, and 4G, and then 5G, and the next one is 6G. So actually, 5G enables 3 kinds of different features or applications. It is high bandwidth, so mobile broadband, ultra reliable and low latency, and then the high density machine-to-machine telecommunication. So this is 3 parts of this 5G applications. And Skylo, for which I work now, is Skylo is on the 5G for narrowband IoT. So let's see from 1G to 5 or 6G, what happens in the technology and what it affects our applications. The first one, of course, is 1G is still analog.
Yeah.
And then we move to 2G when we start using this, they call it broadband, what actually GPRS, and then we go to 3G, UMTS and others, and then we go to 4G, that's LTE, long-term evolutions. Then we start entering the 5G. Especially in this context, for HAPS trial, I will explain about the 5G new radio. So this is the requirements of why people develop the 5G. We see the increase in the number of user devices or user equipment. We see the number of the download upload is going up. So, and we see a lot of technologies out there for fulfilling these demands. For example, in broadband, there are so many standards. We know WiMAX, we know iBurst, as I worked before, and we have others. So all of this become one standard 5G, which we call actually in the ITU, it's like a internet of everything right now for 6G. And this is something that we try to do because in the future, the user can select whatever they want, and the network must be able to supply. When it will happen. So this is a schedule of developing the standards from 3GPP and ITU. So this is something that we are going now. We have this capability. I put Skylo as release 17. Actually, Skylo is pre-release 18 right now. It has new capabilities, lower cost, more reliable, and so on. So this is something that important because the key technology of 5G is, they call it like large scale antenna. Actually, this numbers of antennas. New coding, which means many things like many users use the same infrastructures. Ultra dense networks, meaning a lot of devices can be in a small area. And high frequency communications. This is a must because we need a higher frequency to transmit higher data rates. And for 6G and beyond, we even talk about terahertz and tera gigabit per second. So this is still things under development. So the structure of the architecture, there is a on-demand network function. So if you want IoT narrowband, say 1 kilobit per second or 1 kilobytes of data, you can do this through 5G, the same 5G structure. Why we can do this? Because we use this network slicing, which means the network sliced according to the user's requirements. And to reduce some of this burden to transmit large data, 5G also allow the edge computing, which is now happening, and cloud-based infrastructure also happening now. I want one more slide on this network slicing because it will be important when we do the trial with HAPS for 5G. So network slices enable deployment of multiple virtual networks on the same infrastructure. I'll explain later about this. So on the deployment of 5G, we see a lot of development in many countries, but it falls into two categories. What we call the NSA, that is non-standalone, and what we call the standalone. Let me explain. These 5G non-standalone deployments means we use the 5G NR, that is new radio, but with 4G core system. So only the radio is 5G, but the core system is 4G. So we can roll out the 5G without having to discard all of those 4G system existing today. The other one is standalone. So develop all 5G, including the core system and the radio, coexist with 4G, and they coordinate through these two core networks between themselves. So there are two cores, two radios. In non-standalone, two radios, one core system. So this will explain one of the features, that is a dual connectivity of 4G and 5G non-standalone. And if it is non-standalone, what happened with the frequency spectrum? I think Dr. Dennis Tawan has explained about this on the coexist between 5G and 4G. So what he meant is dynamic spectrum sharing. The same spectrum used by both 5G and 4G. I'll explain later how it is done. So we remember Dr. Arifin has mentioned about 5G as part of the what they call the NTN, non-terrestrial network. So this is a picture of the Qualcomm something like innovations they put on paper, like what they have done and what they expect will be in the future. HAPS actually fall into this 5G NTN. So this is not something outside of the development, but actually this is developed together with 5G. So now I have to make a summary of what is HAPS in the context of using it for the trial for 5G. So let me explain a little bit on this landscape. Everybody knows HAPS is between the height of the tower, only 20, 50 meters maybe. HAPS is about 18 to 23 kilometer. Actually, I fly balloon up to 30 kilometer high, so stratospheric balloon 20 something years ago. And we have LEO 500 to 2,000 kilometer and so on to MEO and to GEO. HAPS will fall under this area of space. So in that area, HAPS has a characteristic different than the others. And this is the characteristic is very important for the application for the trial, and it is for disaster. Like actually, Pak Denny and Professor Gamantio has mentioned about use of HAPS for disaster. So this is something like disaster risk management, DRM. Actually, there is a regulation on this, but I do not know how we will exploit this kind of regulations. So HAPS is like an aircraft. It will be always available. The latency is, of course, very little because it is close. I mentioned the balloon and aircraft. That is right. Depends on these applications on technology. You can use a balloon or aircraft. And lifetime, it depends. Right now, we have balloons for maybe 1 year, and aircraft maybe a few months. So let me summary on what is HAPS. There are two definitions, like what Denny said. That is a high altitude platform system or a high altitude pseudo satellites. So it is like satellites, but much lower. Can be used for fixed broadband, that is transmission links between mobile and core networks and backhauls. ITU has regulation on HAPS, and this is considered as a fixed point. So I think we follow this regulation. There is a global and regionally harmonized designation of frequency bands. We are still working on it. I have no yet kind of national regulation exactly for HAPS. And then actually this is the regulation that I said we have to exploit. That is what we call the Tampere Convention. Using this convention by ITU, it is in 1998 and then ratified by other countries up to 2005 and now, but not ratified by Indonesia. We can use import, use, and even using the same frequency with less regulation applied. What I mean is national regulations, because this is a disaster. So if there is a disaster, hopefully there is help from outside to mitigate this risk, and we need telecommunication systems working. Tampere Convention will enable those countries to send this without too many red tapes of the regulations. So this is something that we have not, I think, comply fully. But at least we have this kind of knowledge about this usage for the disaster. To make it simple, I'll call HAPS is consisting of two different technology. One is lighter than air, that is balloons, and heavier than air, that is like aircraft. So which one we will use for our proposal for using HAPS for 5G communication in disaster area. Let's see. So now we come to the operational aspects. This is three scenarios of our topology of using HAPS. That is as node B, G node B is 5G, let's call it BTS. Band pipe, it means like a mirror, just relay sending up and going down. And there is a complete relay where there is some processing. We will see that we will try to implement this topology A. So the HAPS as G node B. Now the question has been, I think, Pak Denny raised these questions, collaboration or either neutral operators. There are four different HAPS operators. One is dedicated, so mobile operator can use HAPS for its own use. Shared, it's like what we call here a common tower bersama. So one tower for several operators. Neutral host. So this is something that is new kind of business. Like we have this facility and everybody can use as a service. Or government make use of the HAPS for disaster relief, for example. So the use cases of HAPS is many. Greenfield, that is no coverage, we can support. Or white spot reduction, if there is blank spots, also we can support. Or emergency communication. This is what I think, I hope we will see in the end of this presentation. Internet of Things and others. Let's see how it is done. This is a difficulty now. HAPS is covering a larger area, which has been covered by existing terrestrial networks. So there are fixed service, there are mobile service. How we can do this HAPS using the same spectrum, where the spectrum has been used by terrestrial networks. 5G, actually we have the expert here, Dr. Dennis, on this spectrum reforming. LTE use this kind of frames. And when we use a new radio, we can allocate one frame for the new radio for 5G, and the rest is for the existing 4G. When the usage of 5G increase, we can increase the number of the frames. So the more user of 5G, the more frames they can take from the existing 4G LTE. It needs a good, of course, synchronization, time synchronization. But this is, I think, important for our proposal now. Because when we fly HAPS on top of the whole terrestrial networks, it's very difficult to assign a frequency which will not interfere with the rest. So this has been, I think, everybody talking about how to enable 5G in Asia. So this is just an idea. Simultaneous access to low, mid, and high bands. The frequency is open as it's globally. Final and timely regulations, affordable access, and starting to use the IoT now. And this leads us to what trials has been done outside of Indonesia. There are many, not many, several. Of course, the first one may be by these companies, NTT Docomo, Space Compass, you have heard before from the previous presenter. So this is the device, the HAPS, and this is, I think, the first one that we see HAPS as a tower in the sky. This is important. As a tower in the sky, it will also has a problem. It has also has potential. So the second one is in Saudi Arabia. So in Saudi Arabia, it's clear that this is a topology A, HAPS as a G node B. It has an antenna below, and it has communication backhaul from the ground to the aircraft, and people use it just like a ordinary G Note B on a tower. This is on February 5 in 2022. We have another one using another aircraft. This is also topology A. We have another one in Japan. This is actually topology either B or C. So this is like a relay. This is the picture. HAPS as a relay between the ground station and the other ground stations. So from this we learn something that, okay, maybe we can have some dreams. HAPS trial in Indonesia. This is just something that maybe we need to think because of a lot of disasters and others like tsunamis, liquefaction in Palu, where no structure can withstand, right? And this is also the, I think this is, yeah, this is this month picture of the blank spots. And we can see there is no coverage of cellular or 5G in the oceans, either inside or outside Indonesia, because of course, there is no tower. But if you use a tower in the sky, then we can have this coverage. Before that, let's move back a little bit on what this company, Telkom Indonesia, Telkomsel and Telkomsat has done with Starlink. So they use Starlink as a backhaul. It means it's a service provided by Telkomsat to interconnect access network with the core network of Telkomsel. No need to link between hubs and ground system using special radio link using microwave, because we can use satellite. This is the picture. So we can see there is a, I draw here a balloon, and there is satellites, what's it called, satellites from Starlink, LEO satellites. So the satellites will be the one that will give these backhaul functions, because it connects to the Telkom cell core network, of course, through Telkomsat facility. And this become a G Node B complete system, which will enable all of these user devices to connect as if there is a working 5G base station. This is important in the disaster because what people has in their hands is only their cell phone. But without a cellular base station, the cell phone has no use. So if the cell phone cellular tower is damaged, we have another option using hubs. And with Starlink, not only for communication for voice, SMS, or image, but we can also use it for broadband access. This is important because then we can have something like this established in a short time between happening of this disaster and recovering the telecommunications. So the basic setup is backhaul provided by Starlink through Telkomsat. Starlink satellite links is for the LEO satellites is done by them. For the core networks, we use existing 4G network. Remember the NSA deployment. So this is a non-standalone deployment. Half cellular coverage, of course, will be large. 100-kilometer radius is possible, depends on the height and the antenna design. And the coverage can be land or maritime. But the spectrum, this is very important. We can use methodology of coexistence of the spectrum. And the for the core network for this trial, we use the existing 4G core network. Remember this non-standalone deployment. So this is the idea. This is just maybe if we have something like this. So Starlink, IEEE Telkomsel has G.B antenna under this aircraft and the flat antenna on top of this, communicating with the Starlink satellites. I think in less than 1 hour, we can have all of this communication. People can communicate using their own cell phone. Even though there is a big disaster like the one in Palu, liquefaction or disaster tsunami, and this can fly from anywhere in the world to Indonesian territory if we have signed this Tampere Convention. If not, then we should have this one here in Jakarta, for example. So this is important for I think application of HAPS in disaster to show that we have the technology, we have the what you call not demand but maybe a emergency kind of operations. It can happen anytime, but we are ready to mitigate the disaster because of there is no communication. So with this, I will close this kind of short presentation, and I hope if there is any questions, just send me an email. I will try to do my best. Thank you very much to the organizer, and also thanks to the all of the participants. Thank you.
Thank you, Pak Indrawan. We have 10 minutes for question and answer later. Maybe. Okay. I invite. Thank you for explain about the 5G technologies for the future to combine 5G and technologies and hubs, especially in our country, thousands of islands. How hubs and 5G hubs can help, especially for backhaul function for the future. We hope so. Okay, thank you, Pak, again. I will invite Mr. Dr. Arifin Nugroho for the third paper. The significance of HAPS technology. The significance of HAPS technology in supporting the 5G network development. Please, Pak.
Oh, can you repeat the question? The importance of
the significance of HAPS technology in supporting the 5G network development.
Okay.
By Dr. Arifin Nugroho.
Okay, thank you. Actually, it depends on the HAPS technology itself, how long or how high it can operate. Yeah, that's number one. So technology can be using aircraft maybe 1 week, 1 month, but maybe longer, depends on the technology. Balloon can be 1 year, 2 years, depend also on technology. But the business is important, whether there is a regulation on using hubs.
Sorry, Pak. I said I invite third presenter, Mr. Arifin Nugroho.
Oh, okay, please. Yeah.
Please, Dr. Arifin Nugroho, please, for third presentation.
Okay. Thank you, sir. Just a moment. I'm just wondering if I can turn on the. Just a moment. Sorry. Pak, Mas Indrawan, I'm just wondering if
please,
I can do some sharing.
Mr. Indrawan.
Yes.
Stop your sharing, please.
Oh, I do. Still sharing. Let me check.
Can you be off from the sharing session?
Already, yeah.
Oh,
But still run. Your slide still shows in the Zoom template. Our Zoom.
Is it still sharing now?
This is setting up.
Maybe our panitia,
Yeah. Committee, please.
Committee. Hello.
I mean, Ibu. Okay.
I think I have.
Okay, Pak. Okay, Pak.
It's
Okay,
okay.
Yeah.
thank you, Pak.
Ah,
Please,
okay.
Pak.
Okay.
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 Yes, Pak Arifin.
It's
Okay.
internet is okay.
Is it okay now?
Yeah, it's okay.
Okay.
Yeah. Thank you, Bapak Moderator, and good morning, everyone. My talk during the next 20 minutes is regarding the significance or the meaning of HAPS technology in supporting 5G. Let me start with the first fact, which is the NTN itself. So this is the diagram of what's so-called non-terrestrial platform. Non-terrestrial platform is very much needed by the current terrestrial platform in the 5G environment, especially to deal with the new requirements in networking in the future. First of all, to cover in almost every place of the earth with the very high density, and secondly, there will be a requirement of broadband, and thirdly, it's going to be what you call it, a call which need less latency, less than 5 milliseconds, I think. And fourthly, it should assure the ultra reliability. In other words, any connection should be lasting until it ends without any what you call it, any impairment whatsoever. So this is a very requirement or a very philosophical requirement of the 5G and beyond, certainly. So in this case, in order to be able to do so, there will be a requirement not only the terrestrial system, but it's got to be combined with the rest of the network. You see here, for example, we got at the stratospheric, for example, in this case, then followed by the platform in the in the low Earth orbit as well in the geostationary orbit. So this one here represent as a whole what so-called the NT platform, and they can be interconnected from one to another. Okay. Now, yeah, from the little topological point of view, we can consider as follows. For example, the NTN is something in the middle representing only, for example, pen pipe type of topology. In other words, there is no what you call it, no processing whatsoever, rather than only passing through the amplifier, something like that. Okay, and then here we got, for example, a more of what you call it, processing to be put. So can be either NTN based upon very simple repeater types of things, as well as what you call it, onboard processing types of implementations in such a way that it will give in its own right the positive or the pros and cons of this kind of approaches in the future. Okay. Okay, let me skip for the moment to jump to what you call key features of HAPS at 20 kilometers. We are focusing to HAPS because this is the what you call it. This is the objective of this very event. So that's why we are going to a little bit focusing to HAPS at the 20 kilometers. In this case, we are very much interested in incorporating HAPS 20 kilometers to be, to be a part of the NTN itself, because first of all, because the HAPS is only 20 kilometers as compared with the other, for example, satellites, which is at least 500 kilometers away above the Earth, at least. Okay, so the propagation delays and also losses will be very, very low. So in this case, HAPS is having betterment in in giving a good transmission parameters in this case. However, we must be very careful in deciding whether the frequency would be more than 10 gigahertz band. So it doesn't mean that this solution cannot be done. It can be done, but with certain reserve to to certain what you call it mitigation aspect to be incorporated. And then as of course there will be two types of HAPS, but the one which is called air-shaped will be, as Mr. Indrawan has said, it is more or less can be called as pseudo satellites. In other words, it is standing still. In other words, and in such a case, then Doppler effect tend to reduce. Okay, so and then by HAPS, it's also depending on what frequency being available or being given to HAPS. It can be giving a solution with so-called multi-beams in order to increase the throughput. This is the very requirement at the end in the future, as mentioned by Mr. Indrawan, that 5G and beyond should be capable of giving a broadband solution, as well as dealing with the very dense traffic to cope for. Okay, so the multi-beam or frequency reuse would be necessary, and this can be this kind of technology are available to be incorporated into HAPS. Then also HAPS deployment will be very quick and less expensive as compared with other NTN candidates such as satellite, because we do not need to pay for the launcher, for example, in this case. So this is something which could economize the solution. Then the HAPS at 20 kilometers, of course, is also having some limitation because of because the coverage will be limited. So HAPS maybe is having a good solution to certain things. However, it must also be integrated with other technology in order to have a complete complete fulfillment to the objectives of broadband network in the future. Still, if we are to use HAPS at 20 kilometers, there will be two big regulatory aspects need to be resolved, which is first of all, of course, frequencies, okay, and secondly is also what you call it, the license for flying aircraft such as HAPS, okay, which is under EKU. So ITUR and EKU will require some regulatory provisions to be fulfilled by HAPS in this case. Then still another features which is very important in the deployment of HAPS would be what's so-called inter-HAPS links. Why? Because if we are only to talk about one hub, maybe we can fulfill as certain requirements such as capacity conveyance. However, for covering a larger coverage, then we must have some kind of similar hubs to be put somewhere, and as a neighbors or as a constellation, something like that. So that in such a case, HAPS link would be certainly necessary. And if it is true, then optical free space links would be will be commended. In this case, in order to have a very good solutions for the future in terms of traffic capability. Okay, so then last but not least, with HAPS, we expect also that there will be necessary, industries can be, can be developed. For example, in talking about ground terminals, as well as manufacturing the hubs or UAV, something like that. But of course, if we are talking about NTN or non-terrestrial network as a whole, we might also end to the launching business as well, because for example, Indonesia may be having the opportunity, as already been exercised in the past, that NBIAC, for example, can be put there launching station or something like that. So maybe potentially speaking, there will be a good industrial a requirement to be cooked with in the future. So this is about.
Sorry, Pak. I just remind we still have 5 minutes left. Yeah. Mr. Arifin? Maybe we have a problem about connection issue with Mr. Arifin. So we go to the question and answer. For participant will make a question, please raise your hand. What I can conclude for two speaker, HAP is a main advantage system to deploy, to disruption, have a low operational cost, low latency, wide coverage, can be used for broadband service like backhaul, then can help us like country like Indonesia have thousands island. Then our government too have concerning since 2014 to increase the broadband for communication needs. That is from our first speaker. From our second speaker, explain about 5G technologies, how to combine with HAPS in especially in Indonesia. If any question, please raise your hand for participant, please. We have 10 minutes allocation for question session or answer session. Please. Any question, please? We also have from our friends from Hasanuddin University in Makassar. Please, if any question, please raise your hand, please.
Ada Pak Abdullah, itu ada Pak Kemas raise hand, Pak.
Okay, sorry. In page number 2, Pak Kemal, please, Pak Kemal.
Okay. Can you hear me?
Yes, I can hear you clearly.
Okay. Thank you for the opportunity. My name is Kemas. I'm from JSAT Indonesia, Jakarta Rep Office. So earlier I would like to direct my question to Pak Indrawan earlier about the trial proposal that you showed us. You were proposing to use Starlink services, right? So does this mean that a GEO satellite is less effective, or is it unusable? First, because I'm a GEO operator person, and of course, besides Starlink, there are other LEO operator such as OneWeb and O3B, or such satellite operator cannot be used in the design that you just proposed earlier. Yes, those are the questions that I would like to ask. Thank you, Pak Indrawan, for the answer in.
Okay. Better direct, please, Mr. Indrawan.
Okay.
Answer, please.
Pak Kemas, thank you for the question. This is actually something that I have thought which one is better, GEO or LEO. Why I draw this LEO? Because right now Telkomsel has switched using Starlink backhaul instead of GEO. The reason is on the pricing, I believe. But the other point of view is if we use GEO and HAPS is not as stable as we want, we can lose connection if the antenna is not directly pointed to the satellite. The antenna that I draw on the last page of the presentation is the high performance antenna with 3 beams from Starlink, and it has a beamforming, so it can track the satellites automatically. As far as I know, there are several options doing the same for GEO, but it is very big and heavy. So that is only for practical reasons. This is just a kind of ideas. People can jump in and propose better solution. Thank you, Pak Kemas.
Okay. Last question, if any, please open your mic and just speak up, please. Any question? Okay, Pak. I think no one raised hand here. Page 4, page 3, page 2, page 1. Okay. For season 1, we finished the session. And now we enter the session second. I will invite Dr. Anggoro, but what I hear before, Dr. Anggoro cancel maybe, or any representing for Dr. Anggoro. Okay, then the second speaker, I would invite Mr. Walt Anderson, maybe, if any, Mr. Walt Anderson, the need of broadband backhauling from stratosphere. Please, Mr. Walt Anderson. Time is yours.
Thank you very much. I appreciate the invitation. One of the parties has their mic open and we're hearing background noise, so that might be possible to mute that one party.
We can still clear hear your voice.
Okay, I'm going to put a presentation on the screen here. Let me know if you see a presentation.
Okay.
Are you seeing?
Yes.
You see the present? Okay.
Okay.
All right. Avialto is a company based in the UK. We actually have designed a type of HAP that we want to commercialize throughout the world. And we've been talking, of course, to Indonesia, which has a big opportunity to solve the problem of communicating with 6,000 islands. So Indonesia was a market that we looked at as a very important market. We're also talking to governments all over the world about approvals for our service. The issues related to 5G, we've considered the best way to deliver 5G to the ground. And a lot of companies, both satellite operators, are claiming that they can deliver, like AST and Link, claiming they can deliver 5G from low Earth orbit. And you can use the 5G methodology, the protocols, but you can't actually deliver high volume, very high capacity 5G from orbit. And it's also difficult to do that from a HAPS. Our view is we were looking at a goal. We started at the goal of closing the digital divide. So we looked at the world. We looked at the 3 billion people in the world who are not connected or don't have regular access to the internet. And in Indonesia, there are many millions of people that are in that situation without good connectivity. And we wanted to find out a cost-effective way to do it. The situation is different, say, between Japan and Indonesia. Space Compass presentation mentioned that 99% of the people in Japan are connected. So they do not have a big digital divide. Their divide is very tiny. Whereas in Indonesia, there's vast areas of Indonesia that don't have connectivity. And what we're trying to look at is we're talking about areas that now are served only by satellite. We're not talking about the urban areas that have connections with microwave or fiber. And those areas, obviously the way that it's done is mobile operators backhaul their connections from towers back to their central office. Other people get direct fiber connections or microwave connections, and the quality is good. The latency is pretty good. So we're looking at how we can design a network that is cost effective so that the people in the digital divide can actually afford to use it. Satellites have been around for a very long time, and the digital divide has not been closed by satellites. And that's because they're too expensive. Starlink has a different kind of system than Geo, but it's also still expensive. And it does not solve the digital divide because the majority of people living in the digital divide are not going to pay the cost of satellite services. I myself could choose to use Starlink at $120 a month, or I can use a local provider of internet at $30 a month. And I choose, obviously, I'd rather pay less to get the same thing. And people in the digital divide may not have a choice to pay large amounts of money for access. So we're looking at cost effectiveness was the driver in designing our networks, how we could get the capacity. And in order to be cost effective, if you're selling something at a very low cost, you need to sell a lot of that thing. You need to sell a lot of capacity. So we have a type of HAP, an airship type HAP. The prior presenter had mentioned the three types of HAP: balloon, airships, and aircraft. Balloon HAPs did not work. Google Loon tried it for 8 years and finally figured out it does not work. So I've kind of eliminated that as a realistic opportunity. Aircraft type HAPs, the one that's been tested more has been the Zephyr craft that Space Compass has adopted. The problem with aircraft HAPs is they have very limited payload capacity and limited power on board. So in terms of providing a lot of service, a lot of serving many users, they're limited because of the weight they can carry to the sky and the amount of power they can support their radio systems. So far, none of the aircraft type HAPs have been able to support large payloads. That may change in the future, but that's the case. So airships seem to be the answer to how to carry a reasonably large payload and serve a large area. The other issue is between HIBs, high altitude base stations or tower in the sky, and backhaul, sending backhaul down to the ground and letting the ground infrastructure provide that final connection. And we've taken the approach that because, for example, this issue of 5G, if you really want just to put 5G into a remote area, perhaps you're putting it in the middle of a village somewhere where there's a high density and you really want the fast 5G, not just 5G methodology, but really 5G where you're doing gigabit or of capacity or so. If you're doing that, you cannot do that from a high altitude base station because the frequencies that have been allocated for that are very limited, and they don't have the amount of capacity that allow you to really do fast 5G. You can do 4G speeds from a HIBS, high altitude base station, and that's fine. But the other thing is each vehicle that supports a high altitude base station has a limited number of people they can serve, in the same way that a local tower with a base station on board has a limited number of people that they can serve simultaneously. So even though you may put a high altitude base station in the sky and try to serve a large area, you may not be able to serve all the users in that area effectively. So we've taken an approach, a backhaul approach. Here's just the frequencies allocated for HIBs by ITU recently. And the frequencies for HIBs, if you really analyze them, they don't have a lot of capacity. For example, the 703 megahertz to 960 range contains a total of only 110 megahertz of bandwidth, and that's 55 megahertz of that is allocated for a downlink. So it's hard to see how you could do real 5G, fast 5G with 55 megahertz. And especially if you're trying to serve more than one user. If you're trying to serve multiple people holding a cell phone in their hand, 55 megahertz is not a lot of capacity to do. Now the frequencies, the mid-range frequencies, 1710 megahertz to 2655, that were allocated by the ITU have 300 megahertz of bandwidth, and 135 of that is allocated for downlink. And the same issue applies. That's a limited amount of capacity to be providing real 5G. So you can provide 5G type of service with the protocols, but actual, high megahertz bandwidth to a device. But most people carrying a device don't need those high 5G speeds. What they just want is connectivity. And so we've looked at the fact that what we really want to do is serve a larger area. So we have built a telecom payload that is much like a satellite. It's just that we've moved the satellite down to 18 to 22 kilometers altitude. So now we have 16 spot beams, each which can provide a very high capacity, each beam up to 300 megahertz. And using the QAM64 or APSK64, we can get about 1.5 gigahertz per spot beam. Now we can actually deliver capacity to a tower on the ground, or many towers on the ground. And it's possible that if any of those towers need real 5G, we can deliver enough capacity into that tower to let them provide some 5G hotspots in a concentrated area, like the center of a village or some area that has a lot of people or a lot of need. And that allows us to serve a lot more people. Our coverage area from the 18 to 22 kilometers is 240 kilometer diameter circle. So within that 240 kilometer diameter circle, we have 45,000 square kilometers. And we're not trying to cover every single part of, let's say, Indonesia. What we're trying to cover is parts of Indonesia that are satellite only, not terrestrial served, and that have 10 to 12 people per square kilometer. And there are a lot of areas like that in Indonesia that have quite a high population density, but no service terrestrially. In fact, the concentrations are that about approximately 80% of the people are in 20% of the territory. So by covering that 20% of the territory, which has a higher density, you're covering and closing the digital divide for 80% of the people. The rest of that has to be done by regular satellites. But in a cost system, if we're lowering the cost, because our costs, we're going to be able to provide service for about 75% lower cost than a satellite operator to mobile, and we're providing that service to existing operators. So mobile operators, VSAT operators, large banks, and other types of users that are considered telecom operators. So by lowering the cost for 80% of the people in the digital divide, that allows the remaining 20% to be served by satellite, and governments can choose to supplement the cost of that satellite more effectively. If the Indonesian government has to provide satellite service for everyone in Indonesia in a satellite-only area and supplement the cost to where it's cost-effective, where the average citizen can use it, that would be a very expensive proposition for the government. But if they only have to do that for the remaining 20% of the population in satellite-only areas, that's an affordable and realistic approach to close the digital divide. We can close it commercially to 80% of the people in satellite-only areas, and the government can supplement the remaining areas in whatever way they wish, using the existing satellite resources, Starlink or whatever, or the geosats. So our approach is that we're really trying to be practical, and Indonesia has a different need than Japan. Japan would like to cover that 1% of the area that isn't, or 1% of people that isn't covered, very reasonable goal. Indonesia wants to cover a massive amount of territory and millions of people that don't have access. And it's not just mobile phones. So if you're using a high altitude base station, you're only serving mobile phones, and it's going to cost more. But if with our service, we can provide the necessary service not only to mobile operators, the existing mobile operators, we can provide service to VSAT operators, to the banks. There are many areas where you'll see a cash machine, and on top of the cash machine enclosure is a satellite antenna, which is not a very efficient way to do things, because the cost of that equipment to directly connect that cash machine to the satellite is not as effective as having a lower cost alternative in that area, a terrestrial alternative. So by backhauling a lot of capacity down to local cell towers, all the infrastructure like a cash machine can be connected through a mobile network or an IoT network instead of having to go direct to satellite. The networks in the world have been designed with the idea that you have local cell towers on the ground, and the frequencies and operation of the local cell towers on the ground is optimized to provide the best service. For example, when you're sending a signal directly from the stratosphere to a device, the strength of that signal might not penetrate inside a building. If the building is 2 or 3 floors high, it's very possible if you're on the ground floor holding a device, you're not going to get a signal sent from the stratosphere or sent from space. Whereas if you beam the power down, if you provide a backhaul down to a proper cell tower on the ground, that will operate normally and provide service within a fairly large area. So our plan is to provide enough capacity to fulfill the needs of the entire 240-kilometer area that we serve. If that area population density or needs increases, it's very likely that what was once a satellite-only area, an area that only was served by satellite, that people will begin building, companies will begin building infrastructure, fiber or microwave into that territory. And that's fine, because we can continue to serve that area as some of that area is covered by more efficient networks. Because ultimately, there's going to be a continual building, and Indonesia is actively doing that, building fiber and microwave out into the areas that aren't served. But the most efficient way to serve a satellite-only area is not going to be through HIPS. It just doesn't have enough capacity. It won't give you real 5G speeds, and it's costly, just because our one vehicle can provide 23 gigabits of capacity to the ground in our area. A high tower, a tower in the sky, a HIBS, is not going to be providing anywhere near 23 gigabits of capacity to 50,000 different users simultaneously in that area. It's going to maybe serve the average high-density cell tower in an urban area like Jakarta, maybe serves at any moment in time. There may be 400 users on that tower at any moment in time. And so having more towers backhauled through a single HAP vehicle is the most cost-effective. It allows us to lower our costs and allows us to charge a low enough price that mobile operators can actually, they will want to open territory, because right now the mobile operators are being asked by the government, not only in Indonesia, but other countries, to provide service to remote villages. And they do that. They do that by putting a satellite link in, and then they put just a few megabits of capacity, not enough to really fully serve those villages because it's too expensive. They cannot make a profit using satellite connected to a tower. With this lower cost backhaul from a HAP, the mobile operators will be able to profitably open new territory, put enough capacity into the areas they're serving to actually be profitable and to sign up new customers. So it's a little different look, but it comes from purely a very commercial viewpoint of wanting to be the lowest cost provider, so that effectively my customers who buy my service can compete with Starlink, because they'll be actually selling service at a lower cost than Starlink and other operators, because they're getting this high capacity backhaul. So we believe that that is the most strategic approach for Indonesia and for much of the world, other areas of Southeast Asia. We're looking at areas in the United States, Arizona. There are 2 large cities in Arizona, in the state of Arizona. If you go 30 kilometers outside the city limits, you get into areas that have 12 people per square kilometer, but no service. And so there are vast areas all over the world that have these pockets of no service that can be solved economically through this backhaul method. Now, in terms of disaster recovery, if you have disaster, this option to have an airplane with a cell phone tower on it makes a lot of sense. It seems like an ideal thing, because at that point, you don't care if the cost is high for the days that you're in your recovery period. That will be connecting through satellite to that plane. It's a very expensive proposition, but who cares? For that moment in time, while you're trying to connect people back to the network during disaster, cost should not be the option. So we're not saying that HIBS with an airplane type approach that we saw with this plane with the Starlink label on it is not a good idea. That seems like an excellent way to resolve disaster problems. But long-term, every day of the year, 365 days of the year, to be most cost-effective, a backhaul from a HAPS vehicle is going to be the way to actually provide low-cost service long-term. And so that's just a little bit of we've heard a lot of interesting and technical issues here, but we've actually had to solve a problem so that we can actually sell service to a mobile operator that they'll want to buy, or sell service to a fixed wireless operator, a BTS tower operator, or to a bank, or to a large hospital or school. So we think we've found a way to actually close the digital divide about 80%. The other 20% is still going to be solved by satellites or perhaps high altitude base stations. Thank you.
Thank you for Mr. Ward Anderson. Just for your information, our participant here from a telecommunication student, maybe for the future they are a decision maker in communication field. So this is what your explain can be open their mind in the future to use HAPS for a communication alternative like country like Indonesia. Okay, thank you again. Next, I would invite Mr. Edi Setiawan for as a presenter. ITU works and outcomes on HAPS or HIPS, as well as the need for future regulatory works. Please, Pak.
Okay, thank you, Mr. Abdullah, for inviting me to these sessions. Good day, good evening, good morning, good afternoon, everyone. I think because this is a Zoom-based seminar, then I think participants could come from anywhere around the world. So let me share my presentations. I'm sorry that I presented using the PDF format rather than the PPT format. Oh yeah, by the way, can you hear my voice clearly?
Okay, clear your voice, Pak, please.
Okay, great.
And your presentation.
Yes.
Your PowerPoint too. Okay, please, Pak.
Okay, Pak. Just hold on. Okay, can you see my presentation then?
Okay, clear, Pak.
Yeah, full screen. All right. Okay. Thank you. Yes. In this occasion, I'm speaking on behalf of the ICF, the Indonesia-ITU Concern Forum, and focusing especially on the regulatory aspect of HAPS, which is, I think, an important element to bringing into use the HAPS or HIPS in operations. So this is my point of discussions. And then the next slide is I would like to introduce a little bit about the ICF, maybe for those who don't know about ICF. So ICF, or Indonesia-ITU Concern Forum, was established back in 2013. This is a non-government, non-political, and non-profit organization or community institutions. We are open or inclusive to any individual or professional membership for Indonesian citizens only. ICF is oriented on the ITU matters and also open for partnership with all stakeholders, including the government, industry, academia as well. As I said, the ICF is focusing on promoting ITU awareness, capacity building, and advocations on ITU-related matters. So far, we have some partners here, including the HAPS, including the ITU APT of India, the ISGRS of Dr. Arifin Nugroho of IEEE, and we also member of the HAPS Alliance. Recently, last year, we have signed the joint declarations of ICF and ITU in Bangkok, so that with this, we have a very close relationship with ITU in promoting ITU activities, especially in Indonesia. We also have done some seminars, including several seminars on HAPS, started in 2018 up to 2022. And we also have training even on the subsea cable as well and satellite. And we also have trainings on the high throughput satellites for several sessions. Hopefully that maybe in the future we can also host training on HAPS or HIPS. If we talk about HAPS or High Altitude Platform Station, this is based on the ITU articles or regulation 1.66a, which says that HAPS is a station located on an object at an altitude of 20 to 50 kilometer or stratospheric layer, and at the specified nominal fixed point relative to the Earth. So it means that HAPS is like a satellite, a geosatellite. It should have a fixed locations in the stratospheric layer. If you can see from the diagram here, or as well mentioned by the previous speakers, HAPS is much lower than the geosatellite or LEO satellite, but still much higher than the normal civil air traffic route. So this is stratospheric layer, and from the research by multiple institutions, the stratospheric layer has a lower wind speed. So this stratospheric layer is an ideal place to put a platform or flying platform without having any troubles of facing with hurricanes and air turbulence. And so this is the reasons why HAPS has been viewed as the potential technology to provide telecommunication services or remote sensing services and so on. The next is some HAPS applications. It's been mentioned also by previous speakers, but let me reiterate that this is taken from the APT report on HAPS usage in the APT countries. We have some potential use cases, but this is just on limited use cases. It could be expanded more than this one. It could be used for the telecom and broadcasting, for social, financial, and retail, like for banking industries, and so on. Also for natural resource, for example, for the exploration activities, farming, fishery, forestry, for transportations, either maritime, aeronautic, railway, and so on. Also, it could be used for the environmental monitoring or preservation, for example. For example, one of the HAPS developer in US, CI, developed HAPS for monitoring the methane gas emissions, which needs to be monitored for 24 hours nonstop. And this cannot be done by satellite because satellite will be very, very expensive to do that. And then last but not least is the defense and security. For example, for drug smuggling monitoring, border security, and so on. On the left side is some HAPS applications. We can have HAPS to support the mobile cellular as a backhaul, as Walt Anderson explained just recently. Or it could be used for the SCADA or IoT. It could be used for the geolocalization or positioning, just like small GPS kind of applications. It could be used for the broadband wireless access or Wi-Fi internet. So it could provide the internet in the area. It could also be used for supporting remote sensing or PPDR, public protection in disaster recovery, as well as for the last mile. So these are 7 potential HAPS application so far has been viewed that could be implemented in the future. Next is about the spectrum allocation. As been also explained before, HAPS spectrum allocation actually is allocated by ITU through the process called the WRC, World Radio Communication Conference. And before the WRC, there were some discussion or studies under the study groups of ITU, especially ITUR. Once it's been approved in the WRC, then all the spectrum allocation will be put in the what we call ITU radio regulations. For these tables, normally it is put in the radio regulation article 5 of the ITU, sorry. And in this case for HAPS, we have some spectrums allocated, for example, in the 6.4 and 6.5 gigahertz, but this is only limited to actually 5 countries, only for the gateway link in the region 1 and region 3. As you know that ITU has divided the world into 3 regions. Region 1 is Europe and Africa, region 2 is America, and region 3 is Asia Pacific, including Australia. And there's also allocation in 21.4 to 22 gigahertz, 24.25, 25.25. These are all in the region 2. But you must you can see that for spectrum like 25.25 is only used for ground to HAPS and gateway links. And for example, 27 to 27.5 is only used for the HAPS to ground. And also this is 27.9 is used in the region 1 and 3, including Indonesia as secondary basis, but it's only for the HAPS to ground. And then also 31 to 31.3 gigahertz. This is a global allocation, primary. It means that it could be used in those 3 regions without any problem. And then 38 to 39.5 is also global primary, but the HAPS, the HAPS to ground directions for the HAPS ground station is not should not claim protection. It means a kind like a secondary status. And then also 47.2 to 47.5, 47.9 to 48.2 is a global primary as well. So these are the spectrum allocated by ITU for HAPS so far. So for example, in the case of Avialto or maybe Alto or any HAPS developer and HAPS operators, the allocation of the spectrum has been allocated by ITU, and they can use these allocations or the spectrum allocations for the operation of the HAPS. Next is the allocation for the HIPS. HIPS is a new kind of HAPS technology, which is putting the base stations or base stations of IMT on a HAPS. So these are the spectrums that's been agreed in the last WRC 23 for HIPS. Maybe what what Anderson said is true, that the capacity or bandwidth are not so much, but at least these bands could be used for the HIPS to support the mobile solar operator in area where they cannot or they have difficulties to deploy the BTS, the optical fiber, and so on. And actually, for the HIPS to have the backhaul, it must use the HAPS frequency. So on the platform, there will be two kind of stations. One is the base stations, which is the HIPS, and the other one is the backhaul station, which is the HAPS. So in the operation, both frequencies should be used if it is going to be used as the base stations directly to the device. So I will not read one by one, but these are the spectrums allocated for the HIPS, and we have the what we call that division of regions. For Indonesia in particular, we can use the 698, 703, and also the 1.7 gigahertz, as well as the 2.5 gigahertz. But please pay attention on the status of secondary and primary. It means if it is secondary, that means it cannot claim protection and cannot cause harmful interference to other services in the same frequency band. But if it is primary, then it has the priority. It could be protected, and all other services which are primary, so they have to kind of first come first serve kind of basis utilizations if it is primary. Okay. This is about the notification and registrations of the HAPS or stations or HAPS or HIPS in the IMIFAR, or we call it the Master Information Frequency Registrations. So in the ITU regulation or ITU regime, all frequencies going to be used and subject for coordinations, then it should be notified to ITU and will be registered in the IMIFAR for further protections of the spectrum. So if you have a station that don't have, if you have a station which is not registered in the IMIFAR, then I'm afraid that your station will not be protected by other services. This is important, in particular when you have stations in the near border area with your neighbor countries, and this should be protected by this mechanism. We have 11.9, which is the regulation for notifications of, for example, here Earth station or space station, as well as for the high altitude platform stations. We have 11.26 for the HAPS, and you must pay attention on the time limit here. That means this station cannot be brought into use before maximum 5 years. So notification process will take maximum 5 years. If everything goes well, then could be less than 1 year, but we have a 5 years limit of time. For the HIPS, it is 3 years. So for HIPS, it's much faster than the 5 years. So within the 5 year or 3 years, operators and administrations who work hard to make sure that the what you call that, the allocations of the spectrum could be brought into use into operations. Another outcome from the WRC 23 is the modifications of Appendix 4, especially on the Table 2. Before there is no HAPS, but after WRC 23 there is HAPS part in this table actually. So this is important when we have to notify our spectrum to ITU. We have to complete and fill this table. And also some deletions of the resolution related to HAPS 160 and 247, but these resolutions are just the resolutions for instructing ITU to do the study and in the WRC study cycle period. Okay, apart from the ITU, there are some HAPS related documents released by HAPS Alliance. There are 4 documents so far from HAPS Alliance, and it is important for those who wants to build and operate the HAPS. You can refer to these documents by HAPS Alliance. And second one is from the APT, Asia Pacific Telecommunity. So far, they already released 3 documents, APT report on HAPS and HIPS. And now we are, they're still carrying out this, the finalizing the 4th report on the HAPS ecosystem. Hopefully will be done by next year. And these are good reference for those who wants to study or who wants to build and develop and operate the HAPS and HIPS in the future. Next is the potential future works for HAPS and HIPS. As I personally understand that there are a lot of regulatory outcomes in the HAPS and HIPS, but I see there's still some regulatory aspects should be worked out. Number one, what I see is the notification process and software by ITU. So far, correct me if I'm wrong, but so far I don't see any software being available for the HAPS and HIPS notifications process. And then number 2 or secondly is the inter-HAPS link spectrum allocations. So previous speaker mentioning about the free space optic, but I think inter-HAPS link based on the radio frequency is still important as a backup or as an option. And then also I've not seen any ITU report on HAPS and HIPS, especially HAPS and HIPS use case or something like that. So I think this is also important to be developed in the future. On the national basis, I think it's also important to work on the national frequency assignment because the ITU spectrum allocation is just an allocation, but when you want to bring it up into use, then administration should provide the assignment of those service. In case of Indonesia, there will be the ministry degree normally, and also spectrum allocations. And then also national network and service provisioning, as mentioned earlier by the Dr. Dennis Tiawan, that how to operate the HAPS or HIPS, that there should be license. So what kind of license that will be provided for HAPS and HIPS, and this need to be done as well. And last but not least, the equipment type approval. This also has not been seen on the table, what kind of regulation for equipment type approval. In this slide, I would like to pay attention more on the inter-HAPS link. As I said, we have 2 options actually, or actually 3 options. One is using direct free space optic between HAPS, between HAPS. And secondly, we can use the satellite. And the last one, the last one would be using the radio frequency. For the satellite inter-HAPS link or relay, it's been discussed so many times, but we know that the problem with satellite is the delay time and the cost of the capacity. Using free space optic is good because using laser, high bandwidth, but we need HAPS attitude to be very, very controlled and precise, because when it moves, so it will lose the connection. So RF inter-HAPS link would be, I think, would be the best option for that kind of situations. If you see from diagram, the red lines are indicating that the inter-HAPS link to reach the gateway here, it could use, for example, HAPS number 3, which is at higher altitude, let's say at 25 or 30 kilometers. And it could also use the HAPS 4, which is at the same altitude, like 20 or 18 kilometers, as the relay for the inter-HAPS link. Of course, it needs further activities or studies on technical matters like the C over I, EPFD, OOB, or out of band, and also the regulation matters, such as cross-border allocation priority and ITU notification process. Some spectrums that I see as candidates for inter-HAPS link are 24 gigahertz, 31 gigahertz, 38 and 47, 48 gigahertz, which are the traditional HAPS frequency bands or allocations, but also could use the 60 gigahertz, which I think is higher frequency, but such as inter-satellite link, they also use the high frequency in 60 gigahertz. So I think these are the options that could be studied further. As conclusion, I would say that first, HAP is a good option for backhaul or backbone solutions, as presented by Alpha-Alto. HAPS is a good option for last mile solution. Sorry, HIPS is a good solution, is a good option for last mile solutions. And HAPS or HIPS spectrum allocation have been established by ITU via several WRC. As you know, that the first WRC that mentioning about HAPS was back in 1997, and then they agreed on the 47 gigahertz as the HAPS allocation. Then documents on HAPS and HIPS are already provided by HAPS Alliance and APT, and it's good for reference. And last but not least, the future regulatory works are still needed, including the inter-HAPS link spectrum allocations. This is my short bio. With that, I would like to conclude my presentation. Thank you very much, and I will give it back to moderator. Thank you.
Thank you, Pak Edi Setiawan. What you explained before, which is another good topic. Then I will let our participant, if any question, please raise your hand directly to our speaker. Then open your mic, please. Okay. Please, if any question. Okay. I see the. Okay, I don't know. Okay, Pak Edi, could you please open the chat box to see the question from our participant?
Yes, Mr. Abdullah. Yeah, I've seen the questions from Mr. Hendra.
Yes.
Hendra Sumiarsa, right? First, about the research or study on commercial feasibility of HAPS and HIPS. I think there are some studies been done for the commercial feasibility as well as technical feasibility of HAPS and HIPS. And I believe that companies like Alpha-Alto and Space Compass are already doing the same thing. And they see that there is a potential possibility or feasibility to use HAPS. So that's why they want to go to this HAPS business. But for HIPS, I think so far only one company, I think it's SoftBank, is very much eyeing on the HIPS. You know, because for HAPS it's much simpler than the HIPS, because in HIPS you put the base station in the sky. That that kind of challenge from technical point of view, because if the kind of base station is only developed and produced for this purpose, then I think maybe in the term of cost would be much higher than the normal base stations. That's my personal point of view. So you may check for the HAPS economic studies. You can check it over Google as well. I think there are several studies on that. Even in the IEEE website, they also have some articles on HAPS economic and technical feasibility study. The second question, any advantage comparison between HAPS, HIPS, vs MTN plus HAP? Yes, I think there are some studies on the comparisons between technologies I mean, compared with HAPS or HIPS. But I personally don't have that yet, but I think there are some articles on that. And then who will be the most visible plus quick win of taker? I think my personal view is similar to Dr. Dennis Tiawan. I think there is no, I mean, if we try to compare the technologies, I mean, each technology have advantages and disadvantages. So the winner is the one that can use different kind of technology, combine them together, and create it into one kind of solution. So I think that's the company that will win. But if we only focus on one thing, of course, we cannot serve the other thing. I think that's my question. Sorry, my response or my answer, Mr. Abdul. Thank you.
Okay, thank you, Pak Edi. And another participant, if any question, please raise your hand. What Pak Edi explained before gives some us perspective. So many things to do to realize like new technology, but I mean our country very need these HAPS technologies to can connect our thousands of islands, because in the user perspective, they just in their thing they just need bandwidth, but how to provide that is another issue, another technology, another plan, include vendor, academici, so many regulator, like what you explained, Pak Edi. Thank you so much. Then I think I close this session 2. I thank you very much for value presenter. Then I back to Mrs. Rizka, please. Mrs. Rizka, can you hear me?
Yes.
Okay.
Thank you, Mr. Abdullah Basargan, for bridging us to a very productive session. Ladies and gentlemen, as we conclude session 1 and session 2, I want to express our heartfelt gratitude to our esteemed speaker, presenter, and all of you for your active participation. The insights shared today have been invaluable, and we hope they inspire further advancement in HAPS roles in 5G and beyond. Ladies and gentlemen, I would like to remind you that this virtual workshop is again sponsored by PT Telkom Satelit Indonesia Telkomsat.
By enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkom.
Well, we have almost come to the end of our event. I would like to announce that participants need to fulfill the attendance form by the link that provided in the chat box. And now, I'm honored to invite Mr. Edi Setiawan, the chairman of IICF, to deliver the closing remarks for this session. Please welcome Mr. Edi Setiawan.
Thank you, Ms. Reza. Yes, ladies and gentlemen, friends, colleagues everywhere who's still in the room. Surprisingly, that we have still have 111 participants in this room. And I see that this morning we have like 100, almost 160 participants. I think that's amazing for a Zoom meeting, especially for the technology which is considered as new technology. Again, we have heard from morning presentations and keynote speech from ITU, from Ministry of Cominfo, and unfortunately we don't have the keynote speech from the HAPS Alliance, but maybe next time they can participate. And also we have heard presentations from all the speakers, Matsumoto-san from Space Compass, Mr. Indrawan from Caraka, Dr. Arifin Nugroho from IEEE TRS, Walt Anderson from Apelto, and myself from ICF. I think it's been a wonderful meeting, moderated by great moderator, Mr. Abdullah. Thank you very much, Mr. Abdullah, for guiding us in this very short seminar or workshop. Sorry. Yeah, I think personally I see that the HAPS and HIPS is going to be the next milestone in bringing the broadband, especially in area where there is some difficulties to deploy the ground-based terrestrial networks. And as we know that deploying infrastructure is a high capex in some areas. If you take a look in Indonesia case, we have so many remote islands. I personally support the Bakti Kominfo, which is focusing on the USO program, and I've seen so many problems in deploying optical cables, BTS, and even the VSAT stations. Sometimes it's not that easy, because if you go to very deep remote area, then access off-road is not available. You have to use helicopter and so on. So those are the challenges in providing and deploying the infrastructure in country like Indonesia or in a rural area. So HAPS and HIPS is thought to be one of the good solutions. And I think I encourage everybody, especially the researcher, academia, and industry, including the regulator, to look at it more seriously, because this is going to be the next what do you call that? The next solution, or the next platform that we can solve most of the problems, as well as to develop the local industry, And we know that operating HAPS or HIPS is within the air, what do you call that? The air territory, which is under the sovereignty of a country. It's different from satellite, because satellite is in space, then there is no country sovereignty. But for HAPS and HIPS, there is a full control of sovereignty by administration or by country. So I think it's a good technology to be focused with. Regarding to the event itself, I think ICF and ISCRS has been working since 2018. We are promoting the HAPS technology through conferences and seminars, and as well as the online seminars. And hopefully we will continue this to the future. And hopefully by October this year, we are planning to have an offline seminar on HAPS, hopefully. And I would like to invite everybody to participate in that conference. Last but not least, I would like to thank again the main sponsor here, Telkomsat, for allowing us to have this workshop. And also would like to thank, as I mentioned before, the keynote speakers, the speakers, moderators, as well as the committee who is working hard behind the scene. Also MC, Ms. Reza, for also letting us having this workshop. And I think with that, I would like to conclude my closing speech. And once again, thank you very much. And I hope all of you will have the benefits and more or better knowledge about the HAPS and HIPS. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Ladies and gentlemen, distinguished speaker and participant, what an incredible journey it has been. Our virtual workshop on HAPS roles in 5G and beyond has been a convergence of idea, expertise, and shared vision. As we draw the curtain on this event, let's take a moment to reflect on the key takeaways. The first, collaboration. We've witnessed the power of collaboration, how professional, researchers, and enthusiasts from diverse backgrounds can come together to shape the future of our cities. Second, innovation from UAV to satellites, we've explored innovation solutions that transcend boundaries. The sky is not limit, it's an invitation to dream bigger. Third, standardization and interoperability. Our discussion on protocol and interoperability reminds us that progress lies in harmonizing system and breaking down silos. Fourth, implementation challenge and regulatory issues of HAPS technology in 5G and beyond. And I would like to give appreciation to our speakers. Your expertise has illuminated our path. To the organizing committee, thank you for making this workshop possible. To each participant, your engagement has enriched our discussion. As we look up from this virtual space, let's carry this conversation forward. Let's continue to build smarter, more connected city, one idea, one solution at the time. Thank you for being part of this journey. Until we meet again, stay curious, stay inspired, and keep reaching for the stars. Goodbye and take care.
Thank you.
Thank you.
Thank
Thank you.
Thank you.
Thank you, Pak.
Terima kasih.
Terima kasih.
See you next time. See you next meeting.
Terima kasih.
Terima kasih
Terima
Pak
kasih
Indrawan.
Pak Indrawan, Pak Abdullah,
Terima kasih Pak Edi,
Pak Edi.
Arifin, Indrawan.
Sorry tadi jatuh.
ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the leading satellite service provider in Asia-Pacific region, delivering limitless connectivity and discovering new horizons together. Welcome to Telkomsat, Indonesia's premier satellite service provider. As a subsidiary of PT Telkom Indonesia, we pride ourselves on serving the nation by enabling businesses in unserved and undeserved areas. Our strength lies in our extensive satellite network covering Indonesia and extending throughout Asia. We provide comprehensive and innovative solutions to ensure seamless communication for diverse industries. Our commitment to excellence drives us to continually enhance our services, focusing on efficiency, innovation, and superior customer experience. Join us on our journey as we strive to become the